Hello everyone, welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand the configuration of VRF and MP-BGP. Guys, today we are not going to understand the theory parts like what is VRF or what is MP-BGP. If you want to learn the theory about VRF and MP-BGP, you should watch my VRF playlist as well as my MPLS playlist to get detailed information about VRF, MP-BGP and MPLS, those things. Today, just we are going to configure basic VRF and MP-BGP, right, to provide connectivity between two sides of a customer. So guys, in my scenario, you can see I have two customers. This is customer 1, or you can say Lenovo. This is Lenovo side 1, this is Lenovo side 2, right? Another customer is HP. This is side 1 of HP, this is side 2 of HP. Fine. And both customer are connected through service provider network. So this is service provider network. In real time, you will have lots of devices between PE to PE router, right? So R1 is my PE router, provider is router. R2 is also my PE router, provider is router. R3, R4, R5, R6, these are CE router, customer is router. So on PE router, we will configure the VRF, right? And then we will configure MP-BGP. See, on customer side, guys, let's say in the Lenovo side 1, we have one loopback. On the loopback, we are running this network 10.1.1.0/24. Same network, HP is also running on their loopback interface. Fine. And inside the Lenovo side 1, we are running which routing protocol? RIP routing protocol, RIP version 2. So we need to exchange RIP prefixes between R3 and R1, right? And in the same way, we need to exchange eigrp 100 prefixes between R1 and R4. So we will achieve it with the help of VRF. Correct. In the same way, inside 2 of Lenovo, same we are running RIP version 2 protocol. In the side 2 of HP, we are running eigrp S number 100 protocol. Fine. Then we have some loopback over here on R5. We have some loopback on router number 6. And at the end, my goal is what? We need to exchange customer prefixes between side 1 and side 2. So today you will understand how we will achieve this task, how we will provide reachability between N2 and side, like between side 1 and side 2 of Lenovo, as well as between side 1 and side 2 of HP, right? And HP and Lenovo, both customer are using same private network, right? Same private network in their LAN network. Like here you can see inside 1, both customer are using this network 10.1.1.0/24, right? Inside 2, both customer are using 20.1.1.0/24. Getting my point? So now guys, without wasting our time, let's begin. First of all, let me tell you that customer networks are pre-configured, right? Like router number 3 is pre-configured, already configured, right? Router 4, router 5, router 6, these routers are already configured. We are running eigrp number 100, and we are advertising their all interfaces in eigrp 100. In the same on router number 3, we are advertising all interface in version 2. So first of all, let me show you the configuration of customer edge router. And on provider edge router, guys, we will configure everything from the scratch. We don't have any configuration on provider edge router. So like on router number 1, so IP interface brief exclude unassigned. Here you can see we don't have any IP address, just we have one IP address on loopback interface, on loopback 1 interface, right? So IP protocol summary, here we don't have any protocol as well, routing protocol, right? Okay, if you want to remove this, let me do one thing. Say no router ODR. Fine. Now you can see, so IP protocol summary, we don't have any protocol over here. In the same way on router number 2 also, so IP interface brief exclude unassigned. I have one IP address on loopback interface, that's it. Apart from it, I don't have any IP address on physical interface. So IP protocol summary, we are not running any protocol over here, ODR. So let me remove this as well, a router ODR. Correct. Now so IP protocol summary, we don't have any routing protocol over here. And let's say so IP VRF, we don't have any VRF here. And so IP not on router number 1, on router not on router number 2, on router number 1, so IP VRF. So we don't have any VRF here. Now guys, let me show you the customer edge routers like R3. On R3, so IP interface brief exclude unassigned. So you can see on loopback interface I'm running this network 10.1.1.0/24, and on fast Ethernet 0/0 I'm running this network 13.1.1.0/24. So you can see between R1 and R2 I'm going to use 13 network 13.1.1.0/24. After that, if you will check protocol, so IP protocol summary, so here we are running which protocol? RIP protocol, right? If you want to check the RIP configuration, say RIP like this, you can see I'm running RIP version 2 over here, right? No auto summary and network 0.0.0. I'm advertising all interfaces in RIP. Then on R4, R4 is edge router of side 1 of HP. Okay, so IP interface brief exclude unassigned. So IP interface brief exclude unassigned. So here also you can see on loopback interface we are running same IP address, right? And between R1 and R4 I am running 14.1.1.0/24 network. And so IP protocol summary, we are running which routing protocol here? Router eigrp 100, right? So run section eigrp. You can see I am advertising all interfaces in eigrp. Fine. Here I need to add one more command. If you want to add router eigrp as number 100 and say no auto summary, then write it. In the same way guys, on R5 also you can verify the configuration. So IP protocol summary, so we are running RIP version 2 over here, so run section RIP. So you can see RIP version 2 network 0.0.0 no auto summary, and so IP interface brief exclude unassigned. So IP interface brief, right? So you can see on fast Ethernet 0/0 means between router 2 and router 5 I am using 25.1.1.0/24 network, and on loopback 1 I am running this IP address 20.1.1.1, and we are running RIP version 2 protocol here as a dynamic routing protocol. Then let me take you to R6. So IP interface brief exclude unassigned. So IP interface set here. Okay, so on loopback interface, see I'm running same IP address here on R6 and R5. Okay, now so IP protocol summary, here also we are running eigrp as number 100, so run section eigrp. Okay, if you want to add no auto summary command, you can add router eigrp 100 and say no auto summary. Then let me write it. Fine guys, so customer edge routers are already configured. Now let's begin configuration from R1, from the router number 1. First of all, on router number 1 on serial 2/0 I am going to define one IP address, say no set, and IP address will be 12.1.1.1 255.255.255.0. exit. On router number 2 also let me configure one IP on serial 2/0 interface serial 2/0, say no set, and IP address is 12.1.1.2 255.255.255.0. guys, after the configuration I will ask you one question as well, right? So if your VRF concept and MP-BGP concept is clear, you can answer to the question. Otherwise it will be difficult for you to find the answer. Now on router number 1 I have configured the IP on serial 2/0. If I want to check the connectivity between R1 and R2, simply I can ping to 12.1.1.2, and now you can see I am able to ping. That means there is reachability. Now first of all I am going to create one VRF for side 1 of Lenovo, so or you can say for Lenovo customer. So what I will say, IP VRF and the name of VRF Lenovo, let's say. Right guys, here I will define RD value, let's say 1:1, and route target value, let's say 100:100, right? I've defined RD and RT both. Then guys, IP VRF HP for HP customer, and here I am going to define RD value, let's say 2:2, and route target value what? 200:200. I need to create same VRF on router number 2 also. So simply what I will do, so history, I will copy this command and I will paste it on router number 2. So history, history. Okay, so these are my configuration: IP VRF RD RT, then IP VRF HP RD RT. Copy it and let me paste it on router number 2. Correct. Now on router number 1, if you will verify the VRF configuration, you can run command so IP VRF. Okay, so you have two VRF here, HP and Lenovo. For Lenovo, you have configured what RD value, this one. For HP, what RD value you have configured, this one. If you want to check RT value, simply you can say detail over here. It will show you the RT value as well. Like RT value for Lenovo is 100:100, and RT value for HP is 200:200. In the same way, on router number 2 also we can verify VRF. So IP VRF. So we have two VRF here. Fine, guys. Now I am going to assign interfaces in VRF, like fast Ethernet 0/0. Fast Ethernet 0/0 is connected with R3. This interface. So this interface should be in VRF Lenovo, and this interface should be in VRF HP. So let me assign these two interfaces in VRF. Then interface fast Ethernet 0/0. Here I am going to say IP VRF forwarding Lenovo, right? And then guys, here you will define the IP address. IP address 13.1.1.1 255.255.255.0 exit. Then interface F1/0. I'm going to assign this interface in which VRF, in HP VRF. So IP VRF forwarding HP, and then here I am going to define IP what 14.1.1.1 255.255.255.0 and say no sut as well. No sut. Exit. Interface fast Ethernet 0/0. Say no sut. Interface fast Ethernet 0/0. Say no sut. Now, so IP VRF. Again, if you will check VRF, you can see under the HP VRF you have which interface? Fast Ethernet 1/0. That is correct. Under the Lenovo VRF, which interface? Fast Ethernet 0/0. That is correct. And so IP route VRF. Let's say Lenovo. So this is Lenovo routing table, guys. Here we have only this network, 13 network, right? So we need to configure what now? RIP routing protocol between R1 and R3. Then we will receive 10.1.1.0/24 network. In the same way, you can check the routing table of HP VRF. So under HP VRF, we have this network, correct? So we need to do same thing on router number 2 also. Let me do it first, and then we will move to dynamic routing protocol configuration. Fast Ethernet 0/0. Say no sut. IP VRF forwarding Lenovo, and IP address 25.1.1.2 255.255.255.0 exit. Then interface F1/0 guys, no sut, and IP VRF forwarding HP, and IP address over here will be IP address 26.1.1.2 255.255.255.0. Now again, here you can verify the routing table of VRF. First of all, you should run this command. So IP VRF. So you can see under HP VRF we have one interface, that is 1/0, and under Lenovo VRF we have one interface, that is 0/0. Correct, right? So IP route VRF Lenovo. Okay, so this is Lenovo routing table, and this is so IP route VRF HP. This is HP routing table. Fine. Now guys, let me take you to R1 again, and let me configure dynamic routing protocol like RIP version 2 between R1 and R3. So router RIP address family IPv4, then VRF, and for which VRF? Lenovo. And then I am going to say no auto summary here, and then I am going to define network command. So either I can run network 13.1.1.0, or I can say 0.0.0. Let me advertise all interfaces of VRF Lenovo under RIP version 2, and then let me define the RIP version 2. Now guys, do so IP route VRF Lenovo. Now I am expecting 10.1.1.0/24 network under this routing table, and yes, you can see I have received this network from RIP routing protocol. Fine. So now R1 is learning this network in the Lenovo VRF. Let me do same thing for HP VRF also. For HP, we are going to configure router eigrp number 100, and then here we will define address family IPv4 unicast VRF, and the name of VRF is HP, and then autonomous system number. Autonomous system number will be what? 100, guys. Then say no sut here, no auto summary, sorry, no sut, not no auto summary, and then network. Let me run 0.0.0 network command here, and do so do so IP. Now you can see we have eigrp neighborship here, right? Do so IP route VRF HP. So under HP routing table, you can see we have received same network 10.1.1.0/24, right? But guys, if you will check global routing table, so IP route, in the global routing table we have only two network. One is loopback and one is on serial 2/0. That's in global routing table. We don't have like 10.1.1.0 network or 13, 14, right? Because these interfaces are no member of VRF. Okay. So in the same way, I need to configure dynamic protocol on router number 2 also, because here on router number 1, so IP.VRF Lenovo, in the Lenovo VRF we are receiving this network, right? 10 network. In the HP VRF also we are receiving this network, correct guys? So in the same way, now I need to configure what? R2. Okay, so on R2, first I am going to configure RIP between R2 and R5. So say router RIP address family IPv4 unicast VRF, name is Lenovo, and then say no auto summary version 2, and then network, let me run 0.0.0 command and do so IP route VRF Lenovo. So here you can see I am receiving 20 network now, correct guys? In the same way, I have to configure eigrp as number 100 between router 2 and router number 6. So router eigrp as number 100, say address family IPv4 unicast VRF, and the name of VRF is HP, and then autonomous system number is 100. Say no auto summary here, and network 0.0.0. Now I am expecting eigrp neighborship. So yes, you can see the log message. We have eigrp neighborship. Fine. How to verify the neighborship also I am going to tell you, don't worry. Now if you will check the routing table of HP VRF, so IP route VRF HP, so you can see I am receiving 20 network from eigrp. I am running this network, right? And so guys, IP eigrp VRF HP, and then I think neighbor, yes, this command will show you the neighborship of eigrp for VRF HP. If you will run this command here, so IP eigrp neighbor, you can see we don't have any neighborship because this is for IPv4 unicasting, right? Not for VRF. Okay. So hope configuration till now is clear to you. Till now we have only configured the VRF on both P router. So IP route VRF Lenovo. Okay, so here I have 20 network 20.1.1.0/24 exit interfaces fast Ethernet 0/0, and then so IP.VRF HP. So we have again 20 network in this VRF. Fine. Now we need to configure MP-BGP between R1 and R2 to exchange these prefixes, right? Because see on router number 1, so IP route VRF Lenovo. We have only 10.1.1.0/24 network. We don't have 20.1.1.0 network, right? Router number 2 have 20 network. Like if I will talk about the routing table of router 2, I'm talking about which VRF? Lenovo routing table. Under Lenovo routing table, we have which network? 20.1.1.0/24. On router number 1, under the Lenovo, we have 10.1.1.0/24 network. Now I want to exchange these prefixes between R1 and R2. So we need to configure one routing protocol here. So I'm going to configure MP-BGP here, because you know these are not IPv4 prefixes. These are now VPN v4 prefixes, and to exchange VPN v4 prefixes you have to configure MP-BGP, right? Normal BGP cannot carry VPN v4 prefixes. Normal BGP can carry only IPv4 prefixes, not VPN v4 prefixes. Now let me configure the BGP here. Router BGP AS number 100, and then I'm going to say neighbor. Who is your neighbor? 12.1.1.2, right? And remote AS of neighbor is, let's say, 100, right? I'm configuring iBGP neighborship between R1 and R2. Okay, you can configure eBGP as well, no problem at all. Same command I need to run on router number 2 also. Router BGP 100, and say who is neighbor? 12.1.1.1, and remote AS of this neighbor is again 100. Now I am expecting BGP neighborship between R1 and R2, and you can see we have BGP neighborship, but this is IPv4 BGP neighborship, normal BGP neighborship. If you want to disable it, simply here by default one command is running, guys, that is address family IPv4 unicast, this command, right? If you want to remove this command, simply you can say no, right? And if I will put this command on router number 2 also, you can see now we don't have BGP neighborship. On router number 2 also I am going to remove this command, right? Now do so IP BGP summary, you are not able to see any neighborship, right? So now I need to configure what? MP-BGP. For one, guys, I am going to first configure I am going to activate the neighbor under VPN v4, address family VPN v4 here, VPN v4, and under this you need to activate the neighbor 12.1.1.2 activate. This is VPN v MP-BGP configuration, right? Now in the same way on router number 2 also address family VPN v4, and then let me activate 12.1.1.1, say activate, right? Now MP-BGP neighborship will come up. Yes, you can see the log message. And now on router number 1, if you will run this command, so IP BGP summary, you can see we don't have any neighborship, right? But if you will run this command, so BGP, so IP BGP, so IP BGP VPN v4 unicast all, and then neighbor, so it will show you the neighborship, or you can say summary, right? For the summary information, you can see we have neighborship. This is MP-BGP neighborship, right? And now, guys, so IP BGP, if I am running this command, we are not able to see any prefixes over here, right? So IP BGP VPN v4 unicast, or all, only all. Again, we don't have any network under BGP, right? In the same way on router number 2 also you can verify, so IP BGP VPN v4 all, right? We don't have any prefix because we have not advertised any network, right, under this BGP. So what I need to do now we need to redistribute eigrp and RIP prefixes in BGP, right? So guys, on R1 I am going to now redistribute RIP and eigrp prefixes under BGP. So router BGP is number 100 and say address family IPv4 unicast VRF Lenovo, right? And now here I am going to say what? Redistribute RIP. That's it. And now do so IP BGP, right? See, I'm not able to see any prefix over here, but if I will say VPN v4 here and then all, now you can see we have two prefixes, 13 and 10.1.1.0. and if you will open this prefix in detail, like let's say 10.1.1.0 255.255.255.0, right? Now you can see your prefix looks like this. This is your VPN v4 prefix, right? Not IPv4 prefix. So here you have what? RD value plus your IPv4 prefix. Getting my point? So now R1 have installed these two prefixes in their BGP table, so it will advertise with their neighbor. And who is their neighbor? So IP BGP VPN v4 and all summary, right? Who is your neighbor? 12.1.1.2. so it will advertise to router number 2. So now on router number 2 also, if you will run this command, so IP BGP VPN v4 all, you can see you have these two network, correct? In the same way on router number 1, I need to redistribute eigrp prefixes into MP-BGP. So go to config mode again and say router BGP is number 100 and again address family IPv4 unicast VRF, and which VRF? HPVRF, right? HPVRF. And here I am going to say what, guys? Redistribute eigrp as number 100. And now if you will run so IP BGP VPN v4 all, so you can see we have now prefixes of HPVRF as well as prefixes of Lenovo VRF, right? On router number 2 also, now if you will run this command, you can see we have two prefixes under Lenovo VRF, we have two prefixes under HP VRF, right? And if you want to check particular one, you can see here what VRF Lenovo, right? And HP, it will show you the all prefixes of HP VRF, correct? Now in the same way, like here on router number 1 we have redistributed RIP into BGP as well as eigrp into BGP. In the same way on router number 2 also we need to redistribute RIP and eigrp into BGP, because on router number 1 guys, under BGP table now, under BGP we have 10.1.1.0/24 as well as 10.1.1.0/24. This is for Lenovo, this is for HP, correct? So router number 1 have advertised these two prefixes to router number 2 also, correct? But on router number 2 in the BGP table we have only these two prefixes, right? One under Lenovo, one under HP. But I need to advertise this network also 20.1.1.0, right, on router number 2 into BGP, so that BGP will share these prefixes to router number 1. So on router number 2 also we need to redistribute RIP and eigrp in BGP. So let me take you to R2 now, and on R2 say router BGP S number 100, and again address family IPv4 unicast VRF Lenovo, let's say Lenovo, and then I am going to say what redistribute RIP here, and after that guys address family IPv4 unicast VRF HP, and under HP I am going to redistribute eigrp number 100. And now if you will check so IP BGP VPN v4 all, you can see now we have prefixes of both sides, side 1 and side 2 of both customer under BGP table, correct? Here we have 10.1.1.0/24 as well and 20.1.1.0/24 as well, right? And on router number 1 also you can verify so IP BGP VPN v4 all, right? So here also you can see 10 network as well as 20 network, correct? But on the customer router, like on customer is on R3 so IP protocol, we don't have any remote prefix. Like router 3 have not received prefixes of site 2. Why? Because here on router number 1 we have redistribute RIP into BGP, but we have not redistributed BGP into RIP routing protocol till now. So now what I need to do, I need to redistribute BGP into RIP and BGP into eigrp. On router number 2 also BGP into RIP, BGP into eigrp. So let me do this now. On router number 1 go to config mode and say router RIP address family IPv4 unicast VRF is Lenovo. And now here I am going to say what redistribute, and you can run define version as well, version 2, and then say redistribute BGP ES number 100, and then you can define metric 1, right? In the same way we need to redistribute BGP into eigrp, so say router eigrp ES number 100 and then address family IPv4 unicast VRF HP and then autonomous system number 100, and then I am going to say what redistribute BGP ES number 100, and here you have to define the metric parameters like bandwidth, delay, MTU, these things, correct guys? Now on the customer edge router, like on R3, if you will run through IP protocol, you can see I am receiving this network 20.1.1.0/24. Next stop is 13.1, right? In the same way R4, router number 4 means side 1 of HP, so IP route. This router is also receiving 20 network, side 2 prefix, okay? Now these customer side 2 edge routers are still not receiving remote prefixes, like on router number 5 so IP route we are not learning any remote prefix. So on router number 2 now we need to redistribute BGP into RIP and eigrp. So go to router RIP and then say address family IPv4 unicast VRF what Lenovo, and then version 2, and then guys redistribute BGP ES number 100, and let me define metric 1 here. Then router eigrp ES number 100 address family IPv4 unicast VRF HP, and then autonomous system number 100, and then say what, redistribute BGP is number 100, and say metric components. Correct. Now on router number 4 and router number 5 and router number 6. Now you can see I am learning side 1 network, right? In the same on router number 6, show IP route. Yes, I am learning side 1 network, 10 network. And now let me verify these two sites are able to communicate with each other or not. From router number 3, I am going to ping 20.1.1.1 and source 10.1.1.1. Now why ping is not working? So as I told you, I will ask one question to you. So that's all for today, guys. If you have learned something from this video, please hit on like button. If you have not subscribed the channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today.